Hello guys, welcome to Brain Code. In today's video, we are going to solve problem of the day, that is jump game 3. So in the given problem, it is stating that you are given with an array with non-negative integers. Hello guys, welcome to Brain Code. In today's video, we are going to solve problem of the day. So you are initially positioned at start. So they are also giving an index of the array where you are starting. When you are at index I, you can jump to I plus array of I or I minus array of I and check if you can reach at the last any index with value 0. So you just need to find if there is any index with value 0. Give me a second. Okay. We are given with an example 4, 2, 3, 0, 3, 1, 2 and the start index at 5. If you check the indexes 0, 1, 2, 3, 4 and 5, you are starting at the index 5, and what you can do is you can either jump to right or you can either jump to left. So for that, what you're gonna need, so if you jump to the right, you might, so here the index is 5 and the value is 1. So here stating that you can jump to I plus array of I. So the index is 5 and the value is 1. So you can jump to right side. If you check I plus array of I, it means jumping to the right side. So you can reach at the index 6, or else you can minus 5, which is 5 minus array of I. If you do that, you will be reaching 3. And you should also check that the fourth index I is I plus the value is 3. I plus the value 3. So if you do that, you can jump to the right. If you do minus, you can jump to the left. So it's basically, if you're checking, you might get stuck in a loop. Like you can go to 3 and you can go to 3. You can go to 3 and you can go to 3. So you might stuck in a loop. So for that, I'll be explaining more in detail in the iPad. I think the iPad screen is visible now. So we'll take an example. For example, I will be taking an example that is the first example I'll be taking, that is 4, 2, 3, 0, 3, 1 and 2. So we'll be writing the index as well. 0, 1, 2, 3, 4, 5, 6. After writing the index, you need to traverse through the array where you should reach the 0 here. If you are reaching, then you need to return true. If you are not reaching, then you can return false. So if you check now, the first thing they have given an index that where you are starting it. We are starting at index 5. So we can either move to the right by using I plus array of I, that is right, then I minus array of I, meaning we are moving to left of the array. If I plus array of I, if you check now, the index is 5 and the value is we'll check. So the index is at 5 and the value at 5 is 1. So if you see, you can reach at 6. So if you start at index 5, you can reach to index 6. And if you check, the index is 5 and the array of I at index is 1. So you will be reaching 4. So you're having two possibilities. Either you can reach 6, either you can reach 4. So now we'll check for 6. You're standing at here. So you can either move right or either left. So we'll check the right condition. So the index is 6 and the value is 2. And the sum we got is 8. So here if you check the size of the array, we can only reach up to 6. Like max element you can reach is 6. So this is out of bound. So we should handle this case as well. Though and next the index is 6 and the value at 6 is 2. If you do 6 minus 2, that is 4. So you are reaching to fourth index once again. If you see, we are reaching fourth, and if you try to like move right or left, once again you'll be going out of index, out of bound. That is, if you move to the right, you will be going to 7, or if you move to the left, that is 4 minus 3, you will be moving to 1. But what we can do is, if you see carefully, we have already visited 4. So if you are already visited 4, we should not go into that, should not check one more time, because we have already visited 4. So for that thing, what we can do is, we can keep a visited array, and you can mark, if it is reached, we can mark it as I. By using that, we can handle this edge case, that is loop edge case. For 6, you can reach 8, that is wrong, and you can reach 4, which is already visited. Now we'll be checking for 4. For moving right, the index is 4 and you're having the value of 3. 4 plus 3 is nothing but 7. So you will be reaching 7. That is not possible because the size of the array is 6. And now moving to the left, you're having 4 minus 3, which is equal to 1. So you can reach at index 1. Now we'll be checking for 1 as well. If you want to move to the right, that is index is 1, value is 2, that is you can reach at the index 3. And if you want to move to the left, the index is 1, the index is 1, the value is 2, which is minus 1. This is not possible. So there is one more case, that is we need to handle minus 1. We need to handle minus 1 edge case as well. So if you check for the 3 now, before you are going to check, you check what is the value at nums of 3. Here the nums of 3 value is 0. So we have reached the value 0. So we can return true. So basically, if you look at this problem, it's an array problem, but deep down, it's a graph problem. And you need to have a visited array where you will be marking whether it is visited or not. And you can use, and you should traverse each and every element in each and every index. So if you check what you can use the algorithm here, it is a graph and you need to use visited. So you can use two algorithms, that is breadth first search and depth first search. So in this video, I'll be using breadth-first search. So how we are going to do that? I'll be writing pseudocode while doing a dry run for this one. Let me erase these as well. So we are given with 4 and the start is at 5. So initially what we are taking. So we'll write a function which gives nums and the start. So what you're gonna do? And you need to return boolean and firstly you need to have a queue contains integer. It is queue. So we are having a queue here, queue, and a visited array as well. Visited, that is, will be so. Firstly, if you know BFS, first we'll be adding the start index at the into the queue. Here the start index is 5, so we'll be directly adding the 5 in the queue. So for that we can write is queue dot offer is start. So what we can do is, as you know, the breadth-first search algorithm, well, queue not equal to is empty, you need to perform by adding all the elements. So first one we have added. So what we're going to do, we are removing this element out. So for that what I am going to do is int k equal to queue dot full. So we know that the first come first out in the queue. So 5 will be getting out, and I told you we need to handle some edge cases. That is, when you are moving to the left, that I should always be greater than 0. So if I is less than 0 or r, and when you are moving to the right, I should always be less than nums dot length minus 1. So for that one, we can do is I greater than or equal to n. It is then one more thing. I told you that if the element is visited, so you need not to perform anything. You need to skip that element. So if visited, it is visited array. If visited of I, then you just need to continue. You just need not to do anything. Just skip. So one more thing. So we'll be checking after getting if these conditions are satisfied, we should check whether the nums of index is containing 0 or not. So if nums of index, that is k, is double equal to 0, then you can just return true. So here, if you check the nums of index of 5 is 1, so it is not equal to 0. So what you can do? You can either move to left or move to right. So for that one, I'll be adding those two conditions. You can either move to the left of the array, you can either move to the right of the array. I plus array of I. Here we are adding the right of the array and q dot offer I minus array of I. So here we are moving to the left of the array. So at the end, if it is not possible, we will return false. So now we'll be using the dry run. So 5 went out and the queue is, now the queue will be containing, that is I plus array of I. Here I is 5 and the value is 1. So we'll be adding 6 and we'll be adding 4 as well. Now in the next iteration, you'll be getting 6 out. So we will be getting 6 out. So we got 6. So we need to check if k if k, check if k is less than 0. No, if k is greater than or equal to 6. So here n is 7. And whether it is visited? No, it's not visited. So I'll take a visited array, right? And we have visited, I'll be taking index 0, 1, 2, 3, 4, 5, 6. And I have visited, I'll be putting 1. So check for the right, which is 6 plus 2, which is 8. 8 is not possible. So we'll be adding 8 here and we'll be adding, which is 6 minus 2. That is nothing but 4. We have added 4 as well. Now in the visited array, we'll be making 6. Now we will be removing 4 from the queue. Now we got 4 from the queue. And we can add one statement, that is, forgot to add here. Visited of k is equal to 1. So when you got 4 out, now you will be checking, move to the left and right. Now check by moving to the right, which is 4 plus 3, which is 7. If it is 7, so you'll be making visited of I is, and you'll be checking 7. You got 7, so you'll be adding that in the array, that is 7, and you'll be minusing 4 minus 3, that is 1. You'll be adding 1 as well. Now you got 8. So now you got 8 from the array. You are having 4. Now you got 8 from the array. If you check here, 8 is greater than or equal to 7. This condition comes in. Now you just skip it. You need not to perform any action. You just skip it. Then next, you will be getting 4 out. When you take the 4 out, one second, give me a second. I'll be writing this 7 and 1 at the start. 7 and 1. So once this 4 gets out, it will be checking what is the nums of index value. It is 3, and it is checking whether it is visited or not. To check here, it is visited. So here it is 1. So it will just skip because it is visited. Now you will get 7 out. So when you get 7 out, 7 and 1. So when you get 7 out of the queue, you will be checking here. That is, the size is 7 and it is equal to 7. So you will just skip because there is no value after 7. There is no index 7 because the size of the array is 7, but as it is 0 based index, so you will be having till 6. So 7 is less than or equal to 7. So you will be continuing it. Now you will be getting 1 out of it. Now once you got 1, you will be checking whether nums of 1 is 0 or not. If you check here, nums of 1 is 2. So what you are going to do is, at 1 you will be making it is visited, and you will be adding I plus array of I. You check, you are moving to the right, so you will be adding 2 plus 1, that is 3. we'll be adding 3 to the queue and minus 1 to the queue, because 1 minus 2 is minus 1. Then we got 1 out of the queue now. We have got 1 before only. So now we got 3 out of the queue now. Once we got 3 it is not less than 0, it is not greater than or equal to 10, and it is not visited in the array. 3 is nothing here. So and check if nums of k. So here nums of 3 is double equal to 0. Yes, then you just return true for this, because nums of 3 is 0. So this is how we are going to do it. Now let's code the question in the LeetCode as well and submit it. I think you are able to see the screen now. We'll be taking a Boolean visited array. The size will be array.length. And we'll be having a queue. So we'll be adding queue dot offer dot, after adding the start, not equal to queue dot is empty. We'll be taking k, that is queue dot full, and we'll be checking if k is less than 0 or k is greater than or equal to array dot length or visited of I. If it is or if any one case is true, we'll just continue, or else we'll be checking if nums of k of nums of k is double equal to 0, you just need to return true. Not what you need to do is, instead of I is equal, instead of k, instead of k equal to true, then you need to add the left side, sorry, the right side, I plus k plus array of k q dot offer k plus array of k minus array of k. And you just, then we can return false if none is left return. I forgot the semicolon here. Sorry, it's not nums. I think it's array. Yeah. I think everything is passed and we are good to submit. All this question. So that's all for today. If you like the video, consider subscribing the channel and liking the video.